This one.
Oh, we are looking at the scatter plot review packet again, but we are also looking at the homework packet to clarify some questions. Okay, so I haven't passed back those tests yet. I had a couple people, Martine, taking it late in this class. I also was thinking that, actually, I think Miss Morrell went over hers, so maybe I can, I'm never quite sure when I can pass it back. So we'll probably do that today, make sure to get that back to you. I'm waiting for people who are still finding their homework packet, but also I know there's some people who may want to do test corrections on that test, and I'll be available next Wednesday after school for test corrections on that test. Yes?
Can you, if you go to febuary, can you get a higher grade?
Yes, you can. You can come in no matter what your grade was and sit with me to figure out how to do the ones you got wrong. Okay? So the test corrections will happen in tutorial because part of what I want to do is discuss with you and make sure that you've, whatever was holding you up, you now understand. Okay? We good? We found this? Okay. Notice there's some special directions at the top. It's a little noisy today. Brody?
Quiet down, guys.
Brody? Okay, I feel like I'm straining to talk here. Find the equation of the problem with stars. You're supposed to find the slopes on all of these. And the little slopes is the step where you take the y's and subtract them and the x's and subtract them. So for problem number 1, I'm going to go -1 minus a -3. And then 5 minus a -5. You need to be careful with all those negatives. And at the beginning, put them all down. Some of them you're going to be able to change the middle to a plus. Andy, how about you write this down? There we go. So I took this y, subtracted that y, and I'm going to take this x and subtract that x. Now I'm going to say, oh, I've got 2 minuses, I'll make that a plus. 2 minuses, I'll make that a plus. This is -1 plus 3. So +3, so that's a 2. This is a 5 plus a 5, so that's a 10 for a slope. Can we reduce that? Yeah. Might be helpful for us to reduce, make that 1/5. So if all we're doing on the problem is slope, we're going to write that right there. If this is one of the starred problems, you're going to take it a step further. All right? And you may need separate paper for it. I'm going to do this. When we're going to write an equation, you start with the generic y equals mx plus b. And if you know the slope, we just found the slope, you pop that in where m is. Then to continue and find the equation, because the next piece we need to find is b, we pick one of these two ordered pairs and use the x and y to plug in. Which of these would you like to use, the first one or the second? He likes the second one, and it doesn't matter. What does matter is remembering this is the x and that's the y, so I'm going to put -1 to replace y. And I'm going to take 1/5 and times it by 5, which I'm going to write as 5/1 since I'm multiplying fractions. It's a whole number 5, which can easily be turned into a ratio by putting 1 on the bottom. Now what I notice is the 5's cross cancel. I really have 1 over 1 here, or it's probably getting low. Now to get b by itself, I subtract a 1 from both sides. And now I can go ahead and write a new version of this equation. This equation started out generic. First step subbed in a slope. Lastly, I'm going to substitute in a new b. I could have written -2 instead of plus and negative. They mean the same thing. That's what I'm going to go ahead and write over here. Y equals 1/5 x minus 2. Okay, I went through and picked ones where a lot of them the slope ends up being a fraction because of the way that problem sets up, but I picked ones where you should end up with a whole number for b, just by my eyeballs. Okay.
All of them are just the start.
You're going to do slopes for all of them, but you're going to do this step of doing an equation for the ones with stars. Okay? Other questions on this homework packet? Alrighty? Set that aside now, and let's look some more at our scatter plots. You don't have to set it too far. I'm hoping you're going to have time to work on it today. All right, yesterday we started looking at scatter plots, and some of it was review. Martine, we've touched on scatter plots before, but some of it was some new vocabulary, like the word association, which means pattern. Looking at a strong association versus no association, a positive one going up to the right versus a negative one. Okay, we created a scatter plot from a list of data by putting the first side into the X, or list 1, and the second side into the Y, or list 2. We sketched a scatter plot and used one of the stat features to find a linear regression. Okay? For the second page, we had just done something similar with burger information. First, put the info into list 1 and list 2. Second, we made a scatter plot. And third, we did the equation. Lastly, we interpreted that equation. Okay, I wrote your test. Oh, by the way, we're going to have a test next week, and I finished writing it yesterday. And I want to bring your attention to things that we've been working on that I know a lot of you are getting good at this plot and finding that equation. The place people will have the hard time on is writing about it. Okay, so pay attention and make a good effort, each of you on your own at your table today at this right piece. That'll be a spot where you want practice with. It's hard. The other thing that is on your test is stuff like this. That's one of the reasons I'm bringing it to your attention, that in making linear equations, knowing how to do the slope, knowing how to get an equation out of some points is one level of math. Knowing what that equation means is the next level, okay? All right, let's look at burgers 2. Andy, could you read for us, please?
Burger 2 is previous. In
In the previous exercise, you analyzed associated in the amounts of fat, sodium, and fast food hamburgers. What about fat and calories? Here are the data for the same burger.
Okay, same burgers. So go ahead and get into stat edit. What do you notice about the fat numbers? How does it compare to the other burger problem? Same. You may already have that in a calculator. On stat edit. All right. When I open up my calculator, I can see list 1 is still this info. Wait a minute. 19. Maybe it's not. What did I do? 23. Okay, so you're gonna. Oh wait, what the? Oh, maybe this is the. I bet you this is the marijuana info. So here I'm gonna have to. Oh, rats. Oh, I keep doing it. How do I? Wyatt. All right. Hey, Wyatt. How are you?
Good.
Glad you're here now, though. Here we go. You need to clear out your lists. You got to get to the top of the list so the list number is highlighted. Press clear, enter. Okay? And you may or may not need to clear out your lists. You may only need to clear list 2 and enter the calorie info. I had to clear them both. But fats in list 1, calories in list 2, please. Hey, if you're at a table where you never get to touch the calculator, make sure you take your turn. Tell them, hey, I need to learn this too. All right. Double check that your lists are the same length. If they're not, you missed a number somewhere. Pick a number in the middle. Double check that it's matched up with the right partner. 34 and 590, 34 and 590. So it looks like I've got things in the right order. Are you with me to there? Yeah, way ahead of me, huh? Here we go. Same as number 4. I need a scatter plot and a linear regression equation. I go into second stat plot first. I see that it's on. I push enter. On is good and the scatter plot's good. I go to window next and I think about what am I going to need for a minimum x and a minimum y. I see for minimum x I had 0 to 60. That still works. Okay, I see for y I had 0 to 60 also, and that's from a different problem. So I'm going to need to change my y's. My lowest y is 410. What's the highest y?
680.
680. So how about we go minimum of 400 and maximum of 700? Okay, that's in window. In window. Okay, my x's were already set up from yesterday. 0 to 60 will work. I could even make that smaller if we wanted. Do we want to?
50.
Yeah, let's go ahead and make that smaller. Let's start 10 to 50. Do we want to go by ones there?
No.
Or go by twos? Twos, okay. I'm going to need to change the scale on the y's. Should we go by 50s maybe?
Yeah.
You need something that's a good chunk to spread things out. You don't want them too stretched in, but you don't need like by ones. That'd be crazy. All right. So everything's in my list. I've got the right stat plot on, and I set my windows based on eyeballing the min and the max here. Graph. Nice. Cute little scatter plot. All right. Doesn't have to be perfect. Off to the side here, I've got one way down here. We're looking for the pattern, so you don't even need the numbers right now. Okay, just kind of make something that looks to be a matching pattern. Now, some of the vocabulary. Do we see an association? Do they appear to have a pattern?
Yes.
Okay, it looks like some association. And what do we call it when it's going up?
Positive.
Positive. How strong would you call it?
Call it a medium.
Probably medium
Moderately.
or moderate. Okay, it's not super in a line, but I can see what looks like a pattern. All right, now we're going to do linear regression equation. Raise your hand if you know what buttons to push. Tony. Stat. Go to calc. Yes, go down to linreg. On my calculator, it's on 4. I've heard some people say something like 8 or 9, so maybe different calculators. But linreg, AX plus B is what we need. Push enter. I double check the lists. List 1, list 2. List 1, list 2. Yes, that's where I put my data. Enter, 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 enter. There we go. Okay. I've got an equation. I come over here, y equals. They have it in abbreviated form of ax plus b. A looks like 11 plus b looks like 210.9. I'm going to call that 211. So I have rounded a little bit. Does your equation look the same as mine? Okay, now let's interpret this. First of all, this y-intercept is where a line would cross the y-axis. Now I'm going to draw one. You don't need to. But if we were going... Did it come back?
Yeah.
Okay. I'm going to draw one. And what I want you to see... It's that thing that, I think it's the Apple TV that's having issues. Because I can see different things on, everything on here is fine. It's the, oh, there we go. Okay. Silly little thing. Spaghetti. Turn it off, turn it on. Oh, wait. On. You want video? You think that might work better? Okay, it's worth a try. Can you see that? Okay. Can you see my finger? Maybe I gotta push. Now, can you see my finger? Oh yeah, crazy, crazy. We'll see. This is on video. What? Is it a little delayed? Okay. Does camera work better? Oh man. Come on, you can do it. You can do it. All right, here we go. It might look a little bit like My words don't match my hands, okay? What I want you to look at is where does the line hit the y-axis? What do we call that spot right there? No, the origin's down here. Intercept. Excuse me. If I look at a line that kind of goes through all the points, it's not hitting at the origin, it's hitting a little above the origin. Okay? That spot that it's hitting is called the y-intercept. Where do you find y-intercept in the equation?
MF. Or the M.
Not the m. What's m in the equation? Slope. So where's the y-intercept? B, right here, this 211. Now let's remind ourselves, in our X list, this is fat. Along the bottom of your sketch, write the word fat. This is making me mad. Okay, I don't know, do we need to go old school there?
No.
Or do I need to, you know what I think I really need to do? Here.
Pat on the back.
This thing, turn it off, and then turn it back on. I think it just gets tired sometimes and needs a little wake-up call. So, I'm going to do this over here while it's waking up. Let's see if you guys can see me while it's waking up. This line right here, we have fats. Hello, hello. If you haven't written fats along your x-axis, write fats. What's the other thing we're looking at in this?
Calories.
Calories. Okay. So what that line is telling us with a y-intercept here, here's our equation. Y equals 11x plus 211. Yes? Closer. And now I can't see that. This 211 is the y-intercept. That's right here, 211. 211 what? Calories when fats is at what? 0. So what we're doing now, your Apple TV isn't connected to the web network. Check your settings.
Right, go to settings.
Does it just need to do its own thing now? Oh, man. All right. Here we go. Like I said, some days it's old school. Goodbye. Wyatt, do you mind turning the lights on for us? Thank you. If I can have your attention up this way. Memo? Okay, so 211 is calories because it's on the y-axis. And whenever you're on the y-axis, that's at 0 for the x-axis. So if we were going to interpret this, we'd say the starting amount. This is part B down on your paper, so you're writing this down. Of calories for a burger is 211. We did this a lot at the beginning of the year with money, and that was like the starting money people had in their bank, and then over time, things increased. Well, what's increasing here is not time, it's fat. As fat increases, calories go up because now we're looking at the slope. We're looking at how things changes, and it's positive. If this was a negative 11, we would say go down. Go up 11 calories per X, and X is fats. What's the fats measured in? Look at the table. Per gram of fat, per gram of fat. So wait a minute, does that make sense? What it's saying is if you add more fat to the burger, calories are going to go up. Does that make sense?
Yep.
Yes. And now here's a number to it. Does it also make sense that you can start out with a certain amount of calories even if you had a low fat burger? What would those calories be from? What else is in a burger? Bun. What else? Lettuce, tomato, cheese. A little mayo, a little mustard, a little ketchup. Okay, so some of the other stuff contribute a starting amount of calories, and then that burger starts making it go up. The more fatty the burger, the more calories are for the whole thing. Okay, now, do you have something written? I'm still pointing to this. Do you have this written down?
Yeah.
Okay. What I think we're going to do now, especially since we're technology deficient, is there's another problem. It's a table. You're going to do the scatter plot. Okay, and then, there's more. Another table of data. And you need to find the linear, R value. You don't know how to do that yet. Linear regression. You can do everything except the R value in the rest of this packet. You're going to work on finishing this packet before the end of class, and I'll walk around to help. You will have hopefully time to work on that homework packet after you get this done. Questions? Alrighty then, here we go.
Why don't you show me the rest of it? I'll have to get scatter plots.
I know it's long.